Hi everyone, welcome to today's Snacking webinar on accelerating delivery in a major road in Scotland. Just mentioning the housekeeping item, there will be time for question and answer at the end of the presentation. If you can please log your questions in the question box on the control panel, and we will address these questions later on. So I will hand over to Sergio to start the presentation. Thank you.
Thank you everyone for joining me today. I would like to give you some special thanks to our client, Transport Scotland, who kindly allowed us to showcase this project to the wider community. Also, I would like to point out that most of the photos and videos shown in this webinar are courtesy of our client and were created as part of the work carried out for this case study. Any pictures from public websites include a link. So let's start. My name is Sergio Escobar, and I am the BIN Regional Manager for Scotland and Ireland in the UK, and I work in the road sector. I have close to 20 years of experience in the industry, 12 of them in building information modeling, and I have been fortunate to work in very interesting large infrastructure projects, such as the Stockholm Bypass in Sweden, the A83 Stonehenge scheme in England, and recently the A9 dual link project in Scotland, which is one of the largest infrastructure projects in the country. I am part of WSP's digital engineering group in the UK, and my role includes the development of digital methodologies and solutions for the roads industry. I am the BIM manager for the project I will present today, the A83 Rest and Be Thankful. I led the implementation of the solutions and processes showcased today with support of my digital team, of course. I will start with an overview of the A83 Rest and Be Thankful project and how WSP was involved in it, the key challenges we faced, and how we implemented a digital strategy that helped us tackle those challenges. And finally, I will discuss some key takeaways with some time for any questions you may have. So let's start with an overview of the A83 Rest and Be Thankful project. This project is located in the Argyll and Bute region in Scotland. This is a beautiful area with stunning scenery, with lots of places that are secluded, unspoiled and wild, and with many charming towns and villages, some of them located in quite remote areas of the country. Some of the main industries in this region include forestry, tourism, energy and renewables. The A83 is one of only two east-west strategic trunk road network connections between this region and the Central Belt, where the cities of Glasgow and Edinburgh are located. The highest point in the road is a mountain pass called Rest and Be Thankful. To reach this point, the road goes through the western slopes of the Ben Lwyam mountain. The section through the Rest and Be Thankful, also known as Glencroe, is increasingly affected by landslides. These have resulted in regular closures of the road, affecting access to the west of this pass. Given the lifeline importance for communities and businesses served by the route, Transport Scotland commissioned WSP in a joint venture with Argyll to support the development of a resilient and sustainable A83 trunk road. I will describe briefly now the timeline for the project. In October 2020, there was a public consultation on 11 proposed high-level options. In March 2022, in March 2021, the Glencroe Valley was identified as the preferred location for the route corridor, and initial feedback was obtained for 5 alternatives within this corridor. In September 2022, the Argyll WSP joint venture was appointed to take forward the next stages of the design. On the 1st of June 2023, the preferred route for the permanent long-term solution was announced. The plan is to continue the development of the preferred route and publish land agreements and draft orders this winter. The statutory process will take about 1 to 2 years, subject to the need for a public local inquiry. The procurement is estimated to take about 1 year after that. And finally, construction is currently estimated to take about 3 to 4 years. At the moment, we're developing and assessing the preferred route option. So what were some of our key challenges? The A83 Rest and Be Thankful is a major civil engineering project in a sensitive environment, and the necessary planning and legal processes to develop the permanent solution have to be very robust, yet delivered in a time-efficient manner to avoid frustration for businesses and local communities who rely on the road. Therefore, Transport Scotland, our client, set a challenging timescale for completion. In order to meet the project's challenging milestones, the team assessed different strategies to accelerate delivery. One of these strategies consisted in the adoption of innovative approaches focused on digital solutions and automation. Following the comparative assessment of 5 route options, the preferred route for the permanent long-term solution was announced in spring 2023. This comprises of a debris flow shelter of about 1.8 kilometers long over the A83 road. Our digital approach implemented was quite critical to achieve this significant milestone. So let's dive into some of the digital solutions we implemented. Our digital strategy does not consist in a single initiative or an all-encompassing system, but a set of many solutions and improvements that put together have brought and are still bringing significant efficiencies to accelerate delivery. We can divide these into 2 separate groups: digital design and information management. Each group has a set of digital solutions and initiatives, which we'll briefly explore in the next slides. We'll start with context modeling. This encompasses the preparation of a highly detailed 3D model for the project's existing conditions, which empowered project teams to design and assess route options more efficiently and within a real-world context. The existing conditions model was based on LiDAR, point cloud data, and high-resolution aerial photographs. Several route options were able to be developed quickly and efficiently as part of the preferred route identification process. The possibility of designing the routes directly in 3D real-world context played a critical role in the reduction of time it took to develop the options and evaluate their impact against engineering, environmental, and economic criteria. Our design technology also allowed us to generate compelling and immersive visual presentations for our client and other stakeholders very quickly. The technology we used provided a set of powerful analysis tools. For example, changes could be made in the view style to visualize contours and underground elements. Team members could then perform different kinds of measurements directly in the 3D model, including linear 3D distance, 2D distance slope, and area statistics. These tools enable team members to view cross-sections of the road corridor dynamically, as well as inspect the geometry of the vertical alignment. We also had tools that allowed us to visualize light and shadows at different times of the day for any selected date. This was very useful for the environmental and tunnel operation teams. Properly scaled 3D objects, such as construction equipment and vehicles, could be quickly placed on the model to help with the assessment of space constraints, constructability, and maintenance operations. We're still using the 3D visualization model during the development of the preferred route option. This is a very powerful asset for the entire project team, as they can explore the proposals at their leisure, and the model gets updated regularly as the project progresses. Furthermore, we have carried out drone surveys in the area, and the resulting point clouds can be seamlessly integrated with our 3D visualization model to provide an outstanding level of detail. This empowers our teams to better evaluate how the design interfaces with existing terrain conditions. We also use the parametric design tools available in our design software. With this, our structural engineers were able to sketch the layout of structures such as bridges, tunnels, and debris flow shelters in hours instead of days. Structural elements were easy to edit and update to test different configurations and alternatives. Our engineers could then assess not only the structure's form, but also its impact on the surrounding area and its constructability. Moreover, designers were able to update structures' layouts automatically if there were any changes in the associated alignment geometry. For the development of the preferred route, we developed tools and scripts to automate some aspects of the design. For example, we created scripts using visual programming that use digital inputs such as the road corridor and the rock surface models, and automate the creation of the geometry for the debris flow shelter structure based on a set of rules. This geometry is then exported to our structural analysis software, also exported to create the 3D discipline exchange model, which is then referenced in our virtual 3D visualization model. This creates a very powerful design method, allowing for multiple interactions of the models to be investigated and analyzed rapidly. Another example is a script we developed specifically for our federated model. This takes the geometry data from our mainline alignment and automatically generates cross-sections at any changed interval as needed. These cross-sections are very useful for the entire project team and allow us to better understand how the design elements for the road interface with each other and with the terrain. Of course, it's not all about the design, but also the initiatives we implemented to improve our information management processes. One of the key solutions is our project members management system. Our project requires a very large number of staff from various disciplines and organizations. This brings difficulties in terms of getting the right data in a timely manner for client approval. Also, in terms of giving quick access to the project's common data environment systems, which the right permissions and the appropriate onboarding. It is worth pointing out that our common data environment systems consist of 5 separate solutions. With our system, and any prospective project member needs to complete an online form, providing the necessary data for approval. When this form is submitted, an automated work is triggered, which saves the form's data in a master list. It then sends the approval request to the project managers, who can review the new member's data and make any adjustments if necessary. And of course, approve or reject the request. If the new member is approved, an automated notification is sent to our system administrator so they can grant access to the new members as per required permission levels and proceed with the onboarding process. The project members' records are displayed in a Power BI dashboard, which is used regularly to track the status of project members, ensuring only active members have access to our systems. Our next example is our digital health and safety risk register. Traditionally, Excel spreadsheets are used to record health and safety risks, with drawings and schedules used as the only means to communicate residual risks. This creates challenges to ensure there is a single source of truth and that all records are synchronized. This approach also misses opportunities to communicate risks more effectively. Our solution encompasses an online health and safety risk register that can be accessed by any member of the team in just one click from our SharePoint site. Any project member that has identified a risk can easily create a new record in the register, which automatically creates a new link record in our design collaboration platform. This in turn allows us to easily geolocate the risks using the federated model. It is worth pointing out that the several locations can be associated to a single risk record. We then use a visual programming tool application to leverage the data in these records and automate the creation of various key outputs to communicate the hazards, including GIS datasets for displaying hazards in a WebGIS platform, Excel spreadsheets for sharing our health and safety register with external stakeholders, and CAD references with hazard triangles and health and safety information boxes populated automatically, which we use in our drawings. It is worth pointing out that we can use all these outputs to display the hazards in our detailed visualization model. There are more solutions that we have developed and implemented to automate our processes, such as our document transmittal system. But in the interest of time, we'll continue with our next topic. Another key initiative is the provision of interactive reports and dashboards that can provide very useful data insights for better decision making. We have already seen an example of this with the dashboards we use to manage the project team members. But also, we created dashboards to help us track the project actions and tasks. We're in the process of developing more useful dashboards, for instance, to better help us track the status of our deliverables. But the example I want to show you relates to our level of information need tool. To give you some context, the level of information need is a term that comes from the International BIM standards ISO 19650. This is the framework that defines the extent and granularity of information to be produced. The level of information need basically specifies what information needs to be produced by each discipline at each project stage. Our framework is subdivided into level of geometrical detail applicable to design models, level of information applicable to asset data, and level of information for documentation, which applies to documents such as drawings and reports. The problem is often that these are very difficult to read and understand. To mitigate this problem, we created a level of information need tool to enhance the team members' experience and understanding of the project's information requirements. This tool displays the required level of detail and level of information for all the project's assets in a single page, which can be quickly filtered based on key parameters such as project stage and discipline. It also displays the level of information for documentation, which lists all the relevant requirements for documents such as drawings and reports. To finalize, I will touch on our knowledge management strategy. As you have seen in my previous examples, we not only have adopted a range of common data environment systems, each with a specific purpose, but we also implemented a few advanced applications and platforms. One of our main challenges is that not all the project team members were familiar with this. In addition, we implemented numerous processes, workflows, and digital tools which were completely new for the majority of the team. As you can see, it was a steep learning curve, and we had to find a way to make this journey as smooth as possible. For this, we use SharePoint as the front-facing platform for the project. Through the SharePoint site, users can quickly understand and access project procedures, such as requesting for a new team member to join the project, or requesting the issue of a new transmittal for processing by the document controllers. But quite importantly, clear guidance in relation to our digital delivery process and technology. This includes links to the key documents, as well as webinar recordings. Apologies, the video is not working, so try again. There we go. Okay. We also have one-click access to key registers, such as our health and safety risk register and our action list. For high-end applications or complex processes, we have standalone online guides, all accessible from our SharePoint site. These are structured in step-by-step sections and include concise text descriptions and bite-sized demo videos. Finally, our SharePoint site has a news and updates section, used to keep the project team informed about any important changes in the project. Each news article has its own page where the relevant details and links are displayed. To finalize this presentation, I'm going to highlight some of the key takeaways or lessons learned from the application of these digital solutions. The first takeaway I want to mention relates to the benefits achieved by our digital strategy. The use of our digital solutions and automation is one of the contributing factors for accelerating delivery in the project and meeting our first key milestone, which was the announcement of the preferred route option only 9 months after we started working on the project. Our initiatives translated into meaningful cost and time savings, and we are confident that they will continue to bring these benefits during the following project stages. My second takeaway relates to the use of data in engineering projects. Any data in projects can be leveraged to automate repetitive tasks and get key information insights to support decision-making, bringing lots of benefits. Case in point, we employed a data-driven approach with many of our processes, some which you have seen in this presentation. Most projects use the ubiquitous Excel to record any type of data and perform calculations with it. And don't get me wrong, I really like Excel, and I believe that the industry would just simply stop without Excel. However, Excel has many pitfalls as a database, such as performance issues and data reliability. It is very easy to mess up an Excel spreadsheet. As such, we use record-based systems, such as SharePoint lists, as opposed to traditional file-based systems. These have great features such as data integrity and integration with other Power tools, and of course, they are cloud-based. My third takeaway relates to the people in the project, basically the project team. After all, the main objective of our digital approach is to facilitate their work. One of the main challenges associated with the innovation is the disruption, or at least the illusion of disruption, that these initiatives could have on our day-to-day work. It was acknowledged that the rapid adoption of new solutions could overwhelm many of the project members, given that this was not their usual way of working. To mitigate this issue, in addition to guidance and training, the digital team staggered the launch of new tools, giving enough time for users to feel comfortable with the use before introducing new ones. In addition, we were the first point of contact in case of problems or questions, and we tried to be readily available to provide user support when needed. The use of these solutions is slowly but steadily shifting the perceptions of many team members, making them more comfortable and proficient with the tools. And they are beginning to see the value of what these innovations can bring. Finally, I want to end up by mentioning that the project has been shortlisted for the Digital Construction Awards in the Best Application of Technology category. The winner in this category will be revealed on the 2nd of July. I believe this recognition is a testament to the hard work of the digital team and the innovative approaches we have taken. Thank you very much. I'm happy to take any questions if you have any.
Thank you, Sergio. Fantastic presentation and congratulations on the shortlist. Just mentioning again, please continue to log your questions in the question box, and I will start with the first question. What digital tools were used to support environmental impact assessment and interface with activities, for example, land referencing and stakeholder negotiations?
Perfect. We have several tools. Our environmental team normally uses our GIS platform, but obviously there has to be a process for us to share the GIS to cut information to GIS and the other way around. So we have some automation and processes with that. But we also have a proprietary system called Pinpoint, which is our stakeholder and property land information management system, which is very secure. So they use that tool quite a lot as well. And finally, for public engagement, we have a website which is called Story Map and is based on in a ArcGIS system, and that allows us to basically interactively put updates for the public about the project.
Thank you. The next two questions are quite technical. I will start with at what point we should use IntraWorks and then start working on Civil 3D.
Okay, yeah, that's actually a difficult question. So for the assessment of options, we did use both InfraWorks and Civil 3D. The path of least resistance, I would say, is just use InfraWorks just for the high-level assessment of different options. However, at some point, if you want to create drawings and you want to create other types of outputs, sometimes InfraWorks has some limitations. So what we did is basically we did our optioneering design in Civil 3D, but it was basically automatically synchronized with InfraWorks, which allows a sort of very quick turnaround time to assess those options. But I would say if you're starting from scratch, it's a good idea to just start doing the optioneering with InfraWorks, and then as more requests come along for more detailed assessment, then you need to use Civil 3D for sure.
Thank you. The next question is, how did you manage to work with large survey model?
That was also quite tricky because we have LiDAR data with an incredible amount of resolution. So I think we have a point every 2 centimeters or something like that. And of course, your normal systems cannot cope with that amount of data. So we had to reduce the resolution, and we did it in a discrete way, so close to where the options were. We were increasing the resolution a little bit, but out with that, then we reduced the resolution. I think we use 1 meter grid close to where basically the options and airworks footprint, etc., were, and it was like 5 meters out with that. We did those transformations. Well, initially we were using Civil 3D, but it was it's a lot of data and it's difficult to process. We're now using a different type of software called FME, which allows us to do that so much more quickly and manipulate this type of data and reduce resolution, join surfaces, etc., very quickly. So that's normally how we manage the information. And of course, we do have point cloud data that is seen in the full resolution in our visualization models. it works quite well as you know it, because it's not an actual digital terrain surface. It's just the point cloud data, and that, visually speaking, works really well when we combine it with our federated model and with our visualization model.
Thank you. The next question is about the digital images. How have the digital images helped secure support from environmental stakeholders in terms of mitigation and with the stakeholders?
Well, in general, I would say is first of all, it was the models allow us to have this more compelling way of presenting things and understanding the proposals, and those were actually used with some stakeholders to produce images of parts of the road or how things were going to look like, basically, including landowners, for example, to show them basically what the proposals were going to look like. So that allows us to perhaps secure more support from different stakeholders. One of the things that is worth noting, for example, is like showing somebody a line in a drawing, even if it's an aerial photograph, it's never the same as showing the fully fledged 3D model, which you can virtually navigate in real time. So that, of course, provided a lot of benefits in terms of interface with different stakeholders.
Thank you. We receive a lot of questions. I will take the last question. This is a question about how does the level of information need tool works. Do you need to create a parameter list? Can this be applied to other projects?
Thanks. Yeah, the level of information need tool is based on Power BI. Basically, what we do is set up our database of assets, and they have different relationships, like information containers, what types of models they apply to those assets, what stages, what disciplines. So we have a database and a database of images as well. And we use Power Apps, which is part of the Power Platform, to basically maintain that database and make sure that obviously the level of information need is agreed with the different disciplines. And then obviously that refreshes and updates the Power BI dashboard, which is basically the tool, and then that's available online. For that reason, it is very easy to actually use the level of information need tool in other projects. It just needs to migrate the database to wherever the project information is stored, and then you might need to update things to obviously to make sure that the level of information need is specific to that project. But that is not so much of an issue. Case in point, we have the level of information need to use also in the A9 dwelling scheme as well.
Fantastic. Thank you, Sergio, for a fantastic presentation. Really good presentation and really good feedback. Thank you all for your questions, and thank you for your time. For all additional questions that we didn't have time to cover, these will be answered directly by the presenters. By the presenter, you can also see Sergio's contact detail on the screen, and we hope to see you in our upcoming session. So thanks again, everyone, and we will wrap up the session now.
Thank you very much.